Hello everyone, welcome back to the second tutorial of the day. Thank you all for coming on a Wednesday morning. Today we are having deploy and monitor ML pipelines with Python, Docker, and GitHub Actions with Rami Krispin. Rami is a senior data scientist and engineering manager, Docker captain, and LinkedIn learning instructor. He mainly focuses on time series analysis, forecasting, and MLOps applications.
So we're going to do today talk about GitHub Action deployment with Python and Docker. Just a little bit about myself. I'm a senior manager at Docker, managing teams of data science and engineering. I'm also presenting here today after, so it's talking about open source, non-related topics. I'm doing a lot of forecasting, documentation, and MLOps. Open source contributor, mainly in the R language, but also Python. Author of a book about time series and working on next book on time series. I'm also a part of the MLOps with Docker and Docker captain. You can find, if you want to learn more about the deployment, MLOps, there are a couple of tutorials on my GitHub page and on my video, mainly about Docker and deployment. I also recently released a course about deployment in GitHub Action with R and Python, so if you have a link to learning, please check it out. And today we're going to talk about my very favorite topic, forecasting, MLOps, and open source. I would just say that the forecasting is just an example to illustrate, but you can use whatever you want. The goal is to show how you can deploy use GitHub Action to deploy and leverage it to any type of automation that serves the context of open source or all the materials are available in this report.
Excuse me, I have a hard time hearing. Is the microphone on?
It's on, but it's not working, so
I'm looking for the AV to sort out.
I will try to speak louder.
Thank you, yeah.
Okay. If I'm going down, please let me know.
Yeah.
So this is the report. I have a commit that I didn't push, so after the break I will push what everything is there. And the slides are also there. All right, so a quick poll just to understand background. Are you familiar with Docker?
Yes.
Oh, GitHub Actions. Okay. Some different notes. Photo. Okay. I need the domain of forecasting. All right, so I don't need to introduce Docker. Docker is a software to package your code in container and shift it, enable you to shift between different environments seamlessly. GitHub Action is the tool we're going to use today to set automation. It comes as part of GitHub. If you have any repository, you have access for this feature and enable you to schedule and automation workflow on a local repository. So Quarto is a great tool for those who are familiar with our Markdown, which used to be like equivalent, I would want to say, to Jupyter notebooks, but with other features such as we can build websites or start with a simple documentation other than to HTML, interactive HTML, and all the way to write books and so on. And then POSIT used to be the company that used to be Art Studio. So in recent years to POSIT, they released this, and this is a language agnostic. It's a command line tool, so it's coming in the command line. You can use it for Python, Julia, R, JavaScript, and so on. So it's a great tool if you want to create documentation. So we're going to use it today. For forecasting, I'm using Nixla. It's a great library for forecasting. Each workshop I'm trying different library. Previous workshop I tried Dart, also great library. There are many good libraries, Python libraries for forecasting. This is one of my favorites. It's simple to use, very straightforward, no bullshit. All right, I will also say that anything that we're going to use today, there are some alternative tools. So we're going to use today tools that are cloud enterprise and free versions like Docker and GitHub Actions, but you can apply it with different tools. So alternative, one of the most popular alternatives to Docker is Podman, which is the open source project, and give you some similar functionality of containerized code. And there is GitLab and other similar to GitHub Actions. Yes.
Sorry, you're going to speak up.
Okay, so there are other tools out there that's similar to GitHub to give you the same functionality. Similar to forecasting, and anything we show today is Python, but you can do it with R or any other language. So that's the nice thing when working with containers, that it doesn't matter the language. All right, so jumping to the agenda, we'll talk about how I got to use GitHub Actions and Docker. We talk about a little bit of workflow, and most of the time we're going to talk and review design. It's less hands-on, but mainly understand the concept of what you need to do to set the pipeline and how to use it. I assume that writing code to functions to pull data, most of you know, all of you know, and I want to focus on the design. We can go to code and then if we have time, but that's show demo at the end. All right, so jumping to the motivation. So started February 2020. Anyone remember what the highlight of 2020? COVID? Yeah. So at February it was at the news, mainly in the context of China. It was something nobody really knew what was it, and most of the headlines was like something happening in China. We are looking at it, but the news. I went to the archive of CNN and tried to see what were the news at that time. So it was football, Super Bowl. What was the the Super Bowl show with Jennifer Lopez and other singers, and there are things we won't change, right? The politics. And then I came to this, and when someone from the government tell you there's no reason for panic, what happened? Anyway, I forgot where is this from? Semi-Pro, that movie. This is the person, you can find it on YouTube. And the next thing you see people at Costco pile toilet paper, and I'm as a data nerd on the way from a family vacation when the first COVID case hit Santa Clara in California, where we were on base. I was looking up to find the data. John Hopkins released the data, and after 4 days, I created the R package that transitioned the data into tidy format and essentially refreshed the data on a daily basis. And started as a project. At the first days, I didn't realize that it's something that's going to be more than 2 days. And then every night I went and manually ran script to refresh the data. And the first few days it was fine, but then the issues came, and I realized that it's not just something sustainable to do a daily refresh and debug. So that's the last Will Ferrell meme. Also great movie. So I tried to find different solutions, and I came across GitHub Actions, and that led me to Docker. And after trying it, I can tell you there is no good term that there is a learning curve for both, mainly for Docker, but it's perfect. That's my, if I need to summarize this today, it's like if you're not using Docker, I recommend spend the time. There are dividends along the way once you use it and know how to use it in your work. So what is GitHub Action? It is a scheduler, right? We run jobs based on trigger and a CI/CD tool backed into your GitHub, and Docker, similar to the CI/CD tool, enable you to wrap your code and shift it between GitHub. All right, so those are the main tools we're going to talk about today. And to illustrate how Docker works is a very simple. If you're developing on your local environment, and regardless of the language, you're using R, Python, Julia, or any open source language, you set an environment with Docker, you develop inside your code inside this environment, and then you seamlessly shift your code with a container to some remote service. In this case, we're going to use GitHub Action. So if you did some checks and test your code and it passed on your local container, it should pass also and work in the same similar manner on the remote environment. Similarly, if there are some errors, it's easy to reproduce it on your local environment. So that's the magic. Obviously, there is more complexity, but in a nutshell, that's like the benefits of using Docker. It's a learning curve, but once you get there, it's really save you a lot of time. All right, so what can we build with GitHub Actions and Docker? You can use it for automation, right? Some basic CI/CD functionality. If you are running tests, if you have some open source project and you want to run some tests, for example, you have some unit tests that you have deployed, and once you can set every time that there is a pull request or every time that you are pushing code, it's running and send you some report. Data automation, visualization, great use case together with GitHub Pages, and of course, ML applications. This is where we're going to focus today. There are other open source applications. So if you're familiar with iBase, they enable to deploy for free until a certain capacity, different applications like Shiny, Streamlit, and so on with Docker. So it's open and free to use, but there are some limitations. So I'll pause for a second just to talk about those before we are moving forward. So it's not secure. Anything that you're using on the open version, there is a minimal security, so don't put work stuff or anything that should not be open. Compute power, so you get it for free. Okay, you're not getting GPUs or stuff like this, you're getting a machine that can run all its server CPUs. I don't know what is the config, but don't expect to run some deep learning or LLM on top of it. Availability, GitHub enable you to schedule by some time frame, and most likely you will get it by the hour, but if you try to do it by the minute, it may not. So it's if I need to guess, it's based on the availability, and the enterprise user will have priority. And data storage. So you can store some CSV file on GitHub. I will show how to do it today. If someone will ask, I will deny that I will tell you to do it. So it's a bad practice, but for illustration, we're going to set the data in a CSV file and push it. But generally, it's not a data storage. So this is very important. If you have small files, a few megabytes, it's okay, but not beyond this. All right, so let's see how does it work. So when you want to build a pipeline, you start with some scope. In a business context, you are trying to solve some problem, or in an open source, you have some workflow that you want to automate, and you define the scope, and based on this, you define the requirements. And the requirements could be what type of packages do I need to set, what type of version of Python do I need to use, and so on. And there is a step of design of the pipeline. So what are the different components? What function do I need to build to make it run? And then build it and deploy it. And in terms of time allocation, the first component is 90% of the time, and the deployment is the easy part. It's a YAML file with your manifest of the deployment, straightforward. So that's more or less the process or the way that I see how I approach how to define pipeline. So we're going to illustrate with the example of forecasting. Usually I use electricity data from California, where I'm based from. But since we are in New York, so we're going to use demand for electricity in New York by sub-region. So in California there are 4 sub-regions, in New York there are 11. So it's it adds a little bit of more complexity. We will have those 11 providers. We want the pipeline to refresh data daily. So the data is get refreshed on the API every day. If it was hourly, we can go and also set hourly, but there's no point because it's daily. And we want to create forecast and update the forecast every 24 hours. So that's what we want to deploy. So here is the data. After I pulled it, for those who are familiar with time series, it is a very seasonal time series. Beautiful. There are some missing values. So I marked them over here. There was an hour that was not tracked and it's missing. So I just use simple imputation to calculate it. But those are the 11 zones in New York. And that's what we're going to focus. So let's go to the next step, requirements. We want to set an environment. So we'll find Docker image. We want to use for refresh and GitHub actions. And we want the data pipeline to keep updated with the data. And the ML pipeline to refresh the forecast. So it should run, we will tune some model and then deploy just the model with the settings and run it on the refresh process. The last thing we want to use is deploy dashboard with information and also some metadata that we can monitor the health of the pipeline. So let's talk about design. So that's generally the design I use for set this pipeline. It might be overwhelming, but we will go on each component and dive into it. But generally, the data is coming from API. This is GitHub Actions component, and there is the deployment of the dashboard on using GitHub Pages. Familiar with GitHub Pages? And so GitHub Pages enable you to set the website on your repo. And there is the experimentation where we train models, define which model, run some experimentation to test multiple models, and then select for which time series the model that perform best. So let's dive with the data. We're using API. Anyone use the EI API? So the EI API, my favorite API, for example, for time series. It is part of the US Bureau of Energy, and it's a subdivision of the Bureau of Statistics, so it's kind of like tracking data for all the energy in the US. So there is more than 1 million time series available there. It's free, it's open, and they have a very simple API to use. So here's an example. There is a dashboard that you can use to filter what type of CRS you want to pull, and then you will get the schema, and then you can use it to send the GET request to pull the data. So it's straightforward to use it. The next thing is set a container. So that's the Docker file. So Docker file is the manifest of the build. I'm using here a multi-build architecture. Essentially, the idea of multi-build, probably use the wrong term, but essentially I'm using 2 steps to build an image. And when you are building an image, sometimes you are installing a lot of stuff that you are not going to use in the actual deployment. So those are the derivatives that you need to stamp and call it pollution. For example, like if you are compiling into a binary output, all the things that you used to compile are not used after you compile it, right? So similar idea in Python, and there are some examples that you can see. The motivation here is clear, is to reduce the size of the image. It can drop significantly the size of the image. There are examples from giga to 8 megabyte, right? In Python it's different because we are not building a binary output, but essentially all the stuff we are using to set the environment, we are and drop them, and we are just copy the environment already set, and so it saves a lot of size. I did experiment on Python. I have an article about it that showed the floating from the baseline image by gigabyte, like a few gigabytes. So that's the motivation. Think about like when you're using a server, there is some cost, even if you get it free. GitHub has limitation of how much you can use for free. So that's something you need to think about when you're deploying the cost side. And so once I create the image, I develop on the VS Code. I like the dev container extension, which enables you to develop inside a container. And essentially, I set the container that I'm going to use on the deployment in my development environment and use it. So if you clone the repository and want to reproduce it, the only thing that you will need to do, there are 2 things you need. One, there are 2 images. One is I'm using a Mac with Apple Silicon. So it requires a build for ARM 64. And then for Intel build, it requires AMD 64. And there's the thing that GitHub Actions use Intel-based. And so I created 2 images. So if you are using Intel, you have also image for Intel CPU. So you can just uncomment the image to the AMD 64. And the other thing that you need is, if you want to reproduce this pipeline, you need to create API key, set it as an environment variable, and that's it. Technically, that's the only thing that you need. The rest is code base, and it will be, once you launch dev container, it will install the extension and so on. So another thing that you need to think about, that it should be code based when you're setting deployment. That you need to reproduce it. It's easy to collaborate and reproduce. So once we set the environment, the first thing that I'm usually typically do is set a backfill function. So those are the things that we're pulling about, let's say, hourly data for 11 series, and we will pull, I think I set it to reels, so it's a $250,000 observation of rows, and you don't want to do it on the server. The initial pull of the data, you want to make sure that you are tested, see for weird stuff, visualize it. So this is typically I'm doing locally. And so I set a backfill function. And this function essentially initiates the pipeline. And there are two purposes: is to initiate the pipeline and restart. So sometimes you will see the pipeline things get wrong. So you can just use it to restart the pipeline whenever you need it, and rebuild all from scratch. So that this is the functionality, and this function, and this is where I'm using a QuartoDoc, and I like to use on deployment something like QuartoDoc. You can use any other tool like Jupyter Notebook, but the idea that once I finish to run all the components of the pipeline, there is a notebook that I can go deploy it on GitHub pages. I can open it and see the messages, the visualize of the data, and it's easy to debug if something went wrong. Assuming that it's random, right? So there could be some wrong stuff that it's failed, and then you will see an error on GitHub action. But sometimes there are silent errors, and so it's easier to detect when something went wrong to go and see what's going on there. The other thing that I'm using a here I just set like a Vue script to work with the API. And again, this is a special use case because we are working with a specific API, but you can customize it. This is where you bring your own script for your own data, and you can use it unless there is no name. So that's the output. I'm pulling the data, I'm storing it as a CSV file in a data folder, and that's the initial pull. The other thing that I'm doing, so the local script, is setting a metadata file that I'm checking, I'm taking logs. Anytime that I'm either doing a backfill or I'm refresh the pipeline, I want to capture metadata and run some tests. So this is where you want to test and think based on your familiarity with the data, what could go wrong, test it and log it. So for example, this is the trivial, taking the timestamp of when the job ran, the start and end of the request, and then comparing the actual start and end of the data. And that's like one thing that could go wrong, that you're asking for some range, but either it's not available on the API, you're getting different timestamp. So I'm running some tests and make sure that what I asked was what the timestamp is correct. Testing number of observation, checking for missing values. So sometimes there are missing values in the API. So for example, in the weekend, usually before workshop, there will be some issues with the API. So it's a given. And I think this weekend there was also the moving to a day setting time and the change of the hour, and usually this is where the API kind of like things break over there. So you want to protect yourself and make sure check all those things. And so that's after using this data for a couple of workshops, I learned that it's a possibility. So I created a function that imputes the data, missing values, but also log to make sure that I will aware there are some missing values. So again, going back to how familiar with the data and what are the use cases. So sometimes people may say like, this is unacceptable, I'm setting a test and I'm failing the pipeline if there are missing values. So that's the level of tolerance of your test, and based on this, you should define the criteria for success. And then I define, did I update the data? Did I save the data as either true or false, and success based on some criteria. I also leave comments, so I track when on my test either warnings or errors, and I leave the message so that if something breaks, I can go and try to understand where the message came and then go debug. So this is a very fundamental concept when you're building pipeline, take logs. It's important because things will break at some point, so you want to be able to identify as fast as possible and go fix it. Any questions? All right, so now we're moving to the second function we're going to build, is the component of the pipeline to refresh the data. So this is something we're going to use inside the GitHub action, so I'm building it locally, test it, and then I shift the code. And the idea here is to this function going, pull the log, see what was the last refresh time, and set the get request accordingly, and try to pull data and check if there are updates. Based on this, it update the log accordingly. And that's the fun part, the experimentation. And again, this is something I will run locally because of compute. In a real life scenario that you are working with big data, you may use it in some AWS or some Azure or any compute platform that based on your requirement. But in this case, we can run it. We use few CPUs and it's run fast. We're not using some fancy models, and so we are training. And the idea here is to find. I have some assumption about the model, like the time series that I'm using and what model should I use. But using one model for all might not be the right fit. So I'm setting a set of models with different parameters, and I try for each model using backtesting. Backtesting is the time series equivalent to cross-validation in machine learning. So the same idea, splitting into training and testing, the only difference that it's not random split. You split it because it's time series, you split it in a sequential using a sliding window. And you are training your models on a training set and test it on the testing partitions and score it. And based on this, you identify, based on some error criteria, you can select the best one. So that's the experimentation. And again, I use a notebook for this. And that's the output. So we have 11 models. And I ran 2 different sets of models that each running XGBoost, linear regression, and light GBM with different parameters. So you can see that for each, and I used 20 partitions, so each partition is 24 hours. So I use moving the last 20 days, and each time I train the next 24 hours, score it, and move the window, train again, the next 24 hours, score it, and then calculate the average, make root mean square, and the prediction towards coverage. And based on this, I decide, randomly, not randomly, I decide I want to select the model to perform best, or I set like a criteria, but you can, define based on your business case what is your criteria, and then use it. So there is a one-time training process that you select the models, and once you deploy it, unless you see a drift, the models can go forever. So you can see there are 11 series, and each one, between those 3 models. The model 4 use more features, so I guess that's why it worked best than model 3. But you can see that the type of regressor was different. It was not the same for across all 11. So sometimes linear regression do better than XGBoost, and the simple one is winning. Sometimes XGBoost will do better. And again, we log it. Okay, so we say that's our leaderboard, and based on this, we already created a pipeline, and based on the labeling, we pull the data, the models, and refresh the pipeline. All right, so And that's once we have the models and the log of the models, the leaderboard, we can set the model refresh or the ML pipeline. I combine it together with the data refresh, so I have one notebook that refresh the data, and then check if new data available, and I can create forecast, refresh the forecast, and pull the models metadata, and run the models and create new forecast. So that's the forecast refresh component in the pipeline. And again, so we're creating another log for each model. We want to track what was we're creating, this is the forecast. So that's the forecast itself, but we're creating logs. So we have for each series, so this is zone A, you have the timestamp, which the TS stands for the timestamp of the forecast, it's hourly, sequential. You have the forecast, you have the lower and upper prediction interval, the type of model, and the level. And I create also a forecast level. So every day I'm running a model, so then I can do the match with the log. So I label each forecast and give it the date it was refreshed. And based on this, I can do the scoring. And that's the scoring. So you can see the models ran for 2 days. And you can see the average performance of each model on those 24 hours that was stored. The other thing that I'm defining here a success criteria of the refresh. So again, write unit test. I'm checking that I create forecast that it's matched with my horizon. Did I create 24 observation if I want to forecast 24 observation? So those unit tests will save you a lot of time. I will keep talking about unit tests. Hopefully you all believe in unit tests, but they are very important. And then the last component is the dashboard. So once I'm creating the forecast, I'm putting the data, I check the logs, I'm using Warto to set a dashboard, and I just visualize it. It's not fancy. I just created last night, so I could do better. But for illustration, you can deploy. You render it into HTML, and you deploy it on GitHub page. One thing to say that I feel like there is something still not tuned on the pipeline, because technically, once it refreshes the data, it should also refresh the forecast. But generally, that's the things that I'm using to present. You can see you have the metadata and the forecast score, so you can check the logs. You can go wild, like really, if I have the time to sit on it and build something, we can do some more fancy dashboard, check the errors, visualize the errors, check for drift. And this is essentially where the monitoring of your pipeline can go in this dashboard, depending on the purpose, right? So either you want to show the data, or for yourself you want to also have monitoring. So this is the place to do it. And that's how the pipeline looks at GitHub Action. So you can see this is running hourly. For now, I said for hourly. I probably will reduce it, but you can see it run every hour. And the green mark is saying that it passed. One of the things that you, again, like going to unit test, sometimes it passed, but your code didn't run. So there are also caveats about what pass mean in GitHub Action. So you need to make sure that how you test your code, that also it's not, you don't have a sign of failure, that you think everything is okay, I didn't get any emails, but it's actually not doing anything. Okay, so the last component is the pipeline setting file. So I find it super useful to have one file using JSON, you can use any other format, YAML or so on, that have all the manifest of the forecast. So it's including the model settings, the backfill settings, like when the range of the dates I want to pull, the experimentation and so on. Every component here that is something that can be reproduced is over there. And what are the benefits? So let's say that tomorrow I want to take this pipeline and deploy it on, let's say, Texas data, electricity data. The only thing I need to change in this is the API reference for the series that I'm looking for, and that's it. You can run, technically, we can check it at the end of if it's actually working, but you can run it and you will be able to deploy a different pipeline, and the idea is to create something that can be used more than just one use case. So it's a high reproducibility. Okay, so that's an example. So on the JSON file, this is where I'm setting for the API the schema for pulling each of the series. You can see zone E, zone D, the IDs and so on. And this is the modeling. For example, I'm running here a combination of those regression. I'm testing the regression, like GBM, XGBoost, and linear regression. I'm using 3 legs, using some seasonality features, and so on. And it's very clear what I'm using here, and if someone wants to reproduce it, they can go ahead and use the same. It's trackable and easy to reproduce. Okay, so once you set everything locally, you test it. Now we're moving to the deployment, and actually that's the easy part. So you need to deploy in GitHub Actions, you need the following. So you need a workflow file, which we'll dive into it in a second. You need an environment, which is the Docker we created and used. The script to execute, so we have a bunch of scripts I set it inside the Warto doc, but you can run, just Python script or Jupyter notebooks. And you need a trigger. So what is when you want to trigger the criteria to trigger the pipeline. So here is the example for this pipeline. That's a YAML file. You set on your local repository under, you set the .github folder, and then under this you create workflows folder, and this is where you can set many workflows. So this is an example of how we execute this pipeline. So we start with defining the name. Okay, so you see that's aligned with the name over here. We call it data refresh. And then we set the trigger. So in this case, we are using a cron to run hourly at the beginning of the hour. We're familiar with how you set the cron. Okay, so the first one we set it to 0 is the minute in the hour, then the hour, so I'm setting it with the \1, so it means every hour. The next one, I don't know, I'll never went to the next one, but I think the next one is the day of the week, and there is the month, and so on, so you can really customize it to trigger any time that you want. Once you set the trigger, you set the job. And here the job, we start with the environment. So you can see here we have the image. And you see I'm using the AMD version because if you try to run the ARM, it will fail. There are other methods. You can build your Python environment. You can use virtual environment. It might work, but it's less reproducible, right? So some people might prefer to do it. So if you are not familiar with Docker and you want to start, so there are other methods you can use set environment. Docker is not the only one, but it's more robust. And then we start with the steps. So step define, you can have multiple steps, and each one you can execute something, and essentially the way to think about it, you are executing on the shell on the machine you're getting. So I'm starting with check out my repository. So there is a built-in actions and that GitHub provide, or there is like a marketplace that people are building different application for GitHub actions. And this specific one, checkout, enable me to pull the repository that we are working on and change it. So the reason that we're doing it, we want to save the data back to the repository, and we want to be able to load the data, load the settings file. And that's the reason that we use it on the backend. And I reference here, I use the main branch, but you can reference any other. So another nice feature that you can do, you can run on multiple branches. You can do testing. So if you have the dev, prod, or any other type of setting or workflow, you can definitely use it in this type of setting. And this is the execution of the job. So I like to use a bash script that run a bunch of tasks instead of trying to add multiple steps, but you can essentially run also those over here. So the run essentially is run something on the shell. I'm using bash and I'm calling this file, which has essentially a list of items to go. So we want to enter the quarter documentation that trigger the pipeline. We want to save the data. We want to test it. So it's all on this. We can dive into in a second. The last component, I'm using environment variables. GitHub Actions come with the secrets. So I said in the beginning that it's open and not secure, but you can still store API keys that I trust GitHub that they handle it to the best, right? So always could be some leak, but so you can manage secrets. What you should be aware is like the code is running, so it's publicly if it's an open repo, but you can still store secrets. I set on the repository the secrets that I want to use, and just the API key is the only one that needs to be secret. Also store my GitHub user email and user name just to get a secret. I know why. You can use this as a variable. It's not. It's none. And I use it to commit back the changes. But there's another feature, nice feature that GitHub provides. So we talked about unit tests, but what we can do for unit tests. So one of the things that I'm using is PyTest. And PyTest is probably most of you familiar. It's one of the most popular framework for writing unit tests. And I'm writing. There are two approaches to unit tests, right? So at least that I use. I write unit tests on my code. So anytime that I'm running steps, I log it, I test it, and if something fails, I don't want to break the pipeline. I want to know if I break the pipeline, I won't get the logs we want. The PyTest for me is like the last barrier that if there is data integrity issues, it will fail the pipeline. So this is where I put it as a barrier to prevent the pipeline to harm itself. Because once you add some, let's say that you had some issue with the comma separator on the CSV file or so on, it can create like a huge accident, CSV accident, and then you need to restart and debug and so on. So like that's a very good practice to use as a prevent the pipeline to run whenever you think that there are some things that could break. All right, what else can we do? Many. You can set alerts. there is email notification. You can call any API. So essentially, if you want to connect to some social media that support with like a, I'm not using Twitter, but I assume it used to be Twitter that you can send like a tweets from using the API, and the Blue Sky support it, and other social or Slack. So you can essentially, once you run the pipeline and run the forecast, you can send some tweets and people can see or any information. You can, again, data visualization and automation, there are many. Best practices. So start with the set prototype. But I will go to the code because I feel like it's easy to see the code on VS Code and we can over. And maybe I will do it. You can see it well. Okay. So that's my. So I can just go quickly on the, the setting I'm using on VS Code. So I'm using the dev container. I used for many years RStudio until I got to this area that I cannot use better without, and that's where I shift to Python and VS Code, mainly because of the VS Code is probably the second best IDE for any language. But if you're using multiple languages, and I work with Python and Bash and Docker files and so on, and you want to work with containers, that's I feel like why I like it. And I'm not working for Microsoft, so I'm not biased or have any interest, but that's a great feature that any environment, I have a template that I start, I have a dev container settings, and it's enabled to develop in containers. I don't remember when was the last time I didn't write code outside the container. So and it sounds like tedious, but once you use template, it's easy to start project inside the container with minimal effort. We talked about the unit test. So here are the unit tests that I'm running. I'm running a basic checks for the data that I'm using a PyTest. I want to make sure that, for example, do I have the columns that I expect to see? Do I have the right attributes? Any missing values? Number of rows, right? So did I have, is it greater than 0, right? So the basic trivial, I just put it for the example, but I can find 10 more use cases based on how you're familiar with the data. The better the more you're adding more unit tests, I believe it will save you time down the road. So I highly recommend. There are more tools than, it's not just PyTest, there is, I believe, PyData, and there is Great Expectations, and so on. So there are many other tools. Okay, let's go now. So you can see in the repo, it's organized. You have the Docker setting, right? If you want to build from scratch, you can pull it from the Docker app, but if you want, you can produce it. It's all over here. You have this Bash script that build it. And I want to the pipeline. So that's all the files related to the pipeline, and I want to go to the setting. Okay. So that's the manifest of the deployment. What I mentioned before is about prototype. So when I prototype the pipeline, I just want to minimize the data that I'm pulling, but every time that I'm testing, if you're pulling 11 time series, every time you have some error, you need to fix it and try it again. It will waste a lot of time and resources. So I will have a prototype version and I have the full version, like the actual version. And here I'm just setting to pull two series, so it's easy to run all from A to Z, test it and fix anytime until you feel comfortable, and then you run it full scale. So that's the why you need to think about how not to have like some type of sampling as opposed to run it on all before it's go to production. The other thing that you have here is all the path for the data that I use, the logs and so on. I have the definition of the backfill. So this is some parameters that I use on the API, how many observations to offset. So it's all set here. And again, if I will change it to a different series or add here more series, it will just add it and without need to change anything. Maybe on the dashboard, change the labels, but other than that, it's a code base. And we have here the modeling. So we have, I set here another library that I'm not using here, but there is option. So there is a stats forecast. So Nixla has different type of three main libraries for forecasting. Stats forecasting, as the name implies, provides core statistical forecasting model like exponential smoothing, ARIMA, and so on. And the ML forecast is the machine learning. The reason I decided not to use the stats because given the nature of the frequency of the data, we have more granular data. Most likely you will need to use the minimum linear regression and to handle multiple seasonalities, so I decided to just focus on the ML forecast. Let's see if there is yeah, that's it. If now we want to do experiment and we want to, let's say, add more models, we can use it and run the experimentation. And I want to go over now to the deployment.
For the series and the series prototype, do you have to manually change that every time, or is it
Yeah.
automated?
I mean, I thought about also to, the easy way that I thought about how to set it in one place is to add over here, like something like type and prototype or dev production. And then when I read based on this, I can select it to which one to go. What I have now, I believe, on the backfield. So yeah, so you have this. I commented the prototype version I'm using, so I move it to full scale. But yeah, you can do it a little more robust and set it in, because I'm using it in other files. So having it in one file probably better. So we can see, for example, how does the quarter documents work. So I know that most of you are not familiar, so I will promote quarter because it's one of my favorite tools. So essentially, it's a QMD file, that's the extension, and then you define what you want to use, the type of language. So here we're using Python, you can use Julia, R, and so on. And once you set it, it's straightforward. You enter it. You can define if you want to enter it into PDF, HTML, or Word, or any other formats. The nice thing about HTML is that I created this it's create HTML files, and then I created a website using ChatGPT, just a landing page, and you can see if you go the link over here, it will lead you over here, and you can see example dashboard or the backfill. Okay, so for example, it's rendered. Once it's there, anytime that I update the render the file, it will update it once we commit, and you can access it. So I'm trying to see if there is anything. So that's how the file looks like. I try to use as much as I can visualization and try to explain myself if I need to go and debug what would be useful for me to look. So I usually summarize the data, leave comments. So here, whenever there is a missing values, I try to print it. And the summary is of the log. As you can see, missing values were found, missing values were imputed, right? So straightforward, you can understand that, and then I do test if the number of missing values will the same as the number of imputed values, so I can make sure that for me it's a success criteria. Okay, go back over here. You have the experimentation. So again, we can define the experimentation on the settings file. The parameters that we are defining here, if I will find it. So the number of windows is the most probably important, because that will derive how many times you execute it. So for example, we can change it to 30. Let's do it 10 just for the illustration. And we can define the size of the testing partition and the definition how we want to use the prediction intervals of what type. So I'm using conformal distribution. And then I will go to my file, implementation, and I will click this. Hopefully, we won't have some live demo. That's usually I don't have to do live demos, but I will take my chance, and you can see here that it's running on the command line, it's rendering it. So it might take 3 minutes for them running a bunch of models, but that's how Bartle is working, and that's how we work on the deployment. So you need to run into the command line. The last thing I want to show is the bash script that I'm using on the deployment. So as I mentioned, we use the folder to set the workflow. All you need to do is either you can go to the UI of your repository and set a workflow, and there are customized workflows. So there are many Pythons, right? So if you don't want to use Docker, that's the place you want to go to see what built-in workflow for Python are available. Here it's finished to render, and probably will open, render it to HTML, and you can now view it. Or you can go and open a .github and set a workflows folder, and it will automatically GitHub, once it's it will try to run it. And go to see over here what we can do. So you see there are other stuff that GitHub is running anytime they're pushing, so there is some build that's happening on the backend, but we want only the workflow that we set, so we can use this. And let's see, this is ran 40 minutes ago. And you can open it. So there are a couple of steps. It's initial the job, pull the container because we're using container. We use the checkout, so that's the step for pulling the repo. And then that's the data refresh. So if you open it, you can extend it, and you can see this is the rendering of the GitHub, of the Quarto dog, and this is the PyTest. And there are some, that's a nice thing that you can see. There is, I found out yesterday, there is some issues with types. I using NAs or none with the numeric in the same column, so it gives you this warning. So I wouldn't catch it unless I set those tests. So that's a really nice feature. But you can see that's kind of like the last step. It's a warning, so it won't fail. But if it was fail one of the tests, it would break the pipeline. And then once it's finished, it's commit the data, and you can go and see on the log side that you see 38 minutes ago there was a commit, and this commits probably on the log. And it didn't find any new data, so you see it's trying every hour, and until something will available in the API, it will try and then will set, but it set as update as false, the work is successful, finished, so that's the indication on those two columns. That's the log. Another thing to check to see, so here is how you can create a new workflow. So use you can choose from the store, so you can see there are tons of workflows depending on your use case, or you can set up yourself, and that's the YAML. You can write your YAML and make a workflow. There are some repositories where I'm using multiple workflows. So again, the case of dev and prod, and there is the unit test. So set like anytime that I'm pushing to run some tests and so on. Let's see if I missed anything before. Yeah, I just want to show last thing is the bash script that I'm using. So that's the how I use to run the whole thing. I'm executing on the step on the workflow. So essentially, I'm cleaning all because I'm writing HTML files. I'm cleaning the old HTML files, re-render them, copy them to the docs folder, and then I need to define that I want to commit. So I use this git command global. Those are the tests. That's the last barrier before I'm committing, so I want to make sure that nothing is wrong. And that's if there are changes in the repository, distro, it will run this to commit all the changes in the data folder and in the docs. So the docs is where I can use to deploy on GitHub pages. I think that's all I have. GitHub template. Want to hear about GitHub template? How to use it? All right, so I think just to conclude, GitHub Action enables you to schedule a workflow. Great tool, free, up to a certain extent. Great use cases for open source projects. Docker, I think, is the best tool for reproducibility and deployment. Highly recommend check NumFOCUS. Really love this platform. Using it on day to day. It's a great place to, if you're doing documentation, I feel like it's the best tool today available. You can do from just documentation to build website, blog, so on, so on. So very flexible. The last thing that I want to emphasize that it's not enterprise ready, right? So you get it for free. You don't have your database. Ideally, you want to set the database, some Postgres or something like this. So if I would do it in more like AWS, I would use something similar, or I use Airflow with some Postgres or Redshift or any database. But that's more like if you are new to pipelines. I think that's how I started. I learned a lot from just doing it for my own project, and I learned a lot also taking it to my day-to-day job.